Hi everyone, I am Nicola Cavagnetto, as you can see in the bottom part of the slide. I'm a psychologist and I work for a group that is involved in the ARTIMATION project. I'm here to illustrate you the concept of the project and some preliminary results, since we have the validation activities that are actually ongoing for one of the two use cases of the project. But also we are starting the analysis of the first validation of the conflict detection and resolution tool. But briefly introducing ARTIMATION, that is transparent artificial intelligence and automation to air traffic management systems. The ARTIMATION consortium is composed by 4 different organizations. There are the Emanuel Dallens University of Sweden, that are the project coordinators. Then there is ENAC, the École Nationale de l'Aviation Civile France. We have also Sapienza, the University of Rome, and then of course. To start illustrating the first use case, that is the conflict detection and resolution tool, we understood that there are 2 kinds of explainability that can be introduced to artificial intelligence. There are the visual explanations and the algorithmic explanations. So we developed 2 different use cases. The visualization use case of a conflict detection and resolution task, and the algorithmic explanation of the delay prediction of the utilization and optimization of runways. Starting with the validation approach for the conflict detection and resolution visualization, we involved 21 air traffic controllers, and that is a spoiler for later. Now we understand their issue. Again, I don't know what's happening. Okay, hoping it's still there. We involved the 21 air traffic controllers, that were 11 students and 10 experts. And we tested 2 scenarios for each condition. We had 3 conditions that were the black box condition, the heat map solution, and the storyboard solution. We've had 2 kinds of scenarios that were an easy conflict to solve involving 2 aircraft, or a hard conflict to solve involving 3 aircraft. Why? To assess the impact of each visualization on the dimensions of acceptance, usability, human performance, and work performance. Now to end. Right. So we tested 3 visualizations, because we asked ourselves, how can we display an explainable AI solution to air traffic controllers? And so this is the kind of visualization I hope you can see also from the last part of the room, the black box condition. Then we had the heat map condition, with showing go areas in green and no go areas in red. And then we had the storyboard solution, that involved explaining in different times the evolution of the solution of the conflict within the AI. Thank you. So I can show again maybe the first 2, that are the black box here and the heat map here. The heat map condition was also used for the storyboard solution. So what did we find out? Now it's some plot time. What about the trust? What about the trust? From the quantitative analysis of the results, you can see different colors here. The blue color is for students, and the violet is for experts, and the green, the light blue, is for the sum of the participants. And as you can see, probably, I hope, you can see that for the black box, for each level, actually, the students gained more trust for the AI result than the experts that were actually more accepting and trusting the black box solution than the heat map or the storyboard. Talking about situational awareness, that answered the question that will improve my situational awareness of the conflict presented. You can see that students had a high level of situational awareness, or improved the situational awareness, for the black box condition and the heat map condition, while the storyboard, as you can see, is not so effective in creating situational awareness. In fact, we had some feedback, some negative feedback about the storyboard condition, because it wasn't so clear to understand and actually required a more workload, a more interaction with the tool than the other conditions that were more immediate. Also here, the students are actually more gained more situational awareness through the AI solution. And after a qualitative analysis of these, through the briefings after the validation activity with every single participant, we understood that there are ambiguous feedback about the use of XAI in training sessions and in training air traffic controllers, because in students' opinion, showing an XAI solution would help them to create a better mental model of the conflict and to understand how they can see the conflicts differently in their operations in the future. While expert air traffic controllers said that using this kind of AI in training would not help actually the students, because this way the students would not be able to understand how to solve conflicts on their own. And so with an automation failure, with an automation disruption in operations, then they wouldn't be so trained and prepared to solve the real conflicts. Then, these are double notes, I'm sorry for that, but I have to stay short in time. So, for the work performance here, for the conflict detection and resolution tool, also here you can see how the students had higher levels for each condition for the work performance. So, both in increasing accuracy and solving faster the conflicts. In both cases, you can see how the black box condition has the highest ratings, while for the accuracy, the heat map would be better and than the storyboard, while for the fast resolutions of conflict, the storyboard was higher than the heat map. Then we assessed also the neurophysiological reactions to the visualization of the XAI solutions. And we measured it with the EEG to understand also the workload, and there are some interesting results because even if, as you could see before from the plots and from the answers of the people, the workload ratings are actually lower for the heat map solution than the black box or the storyboard, that are actually at the same level. Also, using the two repetitions, so the easy and the hard scenarios. Even if for the black box and the storyboard, the second repetition elicited less workload than the first repetition, in the heat map, the workload increased for the second repetition. But the increased workload is still lower than the other two conditions. And mixing these results with the approach withdrawal results, the approach withdrawal briefly is the unaware acceptance and acceptance of an interface of a new tool that is presented. And so it's being unaware, it's something that is not processed. This is the starting point of the process of recognizing something. And the acceptability has been found to be significantly higher for the heat map condition than the storyboard and then the black box that was actually the less accepted. Even if in the questionnaires and in the debriefs, the traffic controllers told us that the black box was their favorite solution. So this is something that should be assessed more and more to understand why this happens actually, because this is repeat that this is the unaware part of the acceptance. Also, ARTIMATION tried to assess the visual analytics in an immersive way. So, how could we display a solution of a conflict in a 3D environment? So, here you can see a brief video, thank you for the lights again, and where you can find the ranking of the solutions from the worst one to the best one found by the AI. How they can be visualized in a 3D environment, so with a VR helmet. So this will be a 1.5 minute video without audio, so I can go on commenting, or if you have any questions about that, we can try to answer it by now. So this is also how they can interact with the trajectories of airplanes, of aircraft, during the task of conflict detection and resolution, so they can select what, in their opinion, would be the best one or the worst one, also using the ranking from the optimal solution of the algorithm developed. In this case, we use the genetic algorithm that is an algorithm already existing for that is used in ACC. Of course, we didn't have so great feedback about the 3D solution because the main issue would be the lack of seamlessness, let's say, because you know that in air traffic control, you should be aware of everything that is going on in your sector, and if you stop understanding what's going on in your sector because you have to put on and put off VR helmet that would be not so useful in this timeline, let's say, for these times. Maybe in the future it is something that can be assessed. So this was like a little concept of the 3D visualization. Now I can go on with the delay prediction tool that has been developed, trying to assess an algorithmic explanation of the artificial intelligence outcome, not the visual explanation. The underlying idea of this model is that usually you can have the input, you input something in the machine learning or in the AI, you develop the machine learning model, the machine learning model gives you the output, and then the output is presented to the users. The main concept is that we developed three different algorithms that are called SHEP, LIME, and DELEX to show the AI solution to the users. This way, what's different between these three algorithms? Actually, SHEP answers to the question how much each feature value contributed to the prediction compared to the average prediction, providing the explainability showing the parameters that best answer the question about a predicted delay. Like the ferret, LIME provides explanation by training surrogate models to approximate the predictions of the black box model, testing what happens to the predictions when the variation of data is given into the machine learning model, and generating a new dataset consisting of samples of the corresponding predictions of the black box model. So it's iterating the model of the black box and selecting different parameters than the one that the SHAP, for example, provided to the users. And then DELEX is the most user-centric algorithm that we developed within ARTIMATION, because DELEX assumes that the prediction is an approximation of the expected value of the dependent variable given values of different parameters. And so this way, DELEX wants to capture the contribution of a parameter to the model's prediction. This way, the machine learning model DELEX go on learning every time from the input of the air traffic controllers. This way, the air traffic controller is able to personalize the model, let's say, choosing each time the parameters, and the machine learning model would learn step by step and situation by situation, context by context, what are the best parameters to be shown to the traffic controllers in this environment. The validation activities for the delay prediction tool are actually ongoing. So, is there any air traffic controller here in the room? Just one? Just one. Okay, so I'm going to ask you to go to ARTIMATION.eu, not now, because it's a 1 hour task, but less than 1 hour, let's say. Because we are going, but if you know some air traffic controllers and want to help the ARTIMATION project, then make them go to ARTIMATION.eu, and in the section User Events, you can take part to the validation process of delay prediction with something that will take less than an hour, and that's all for ARTIMATION. Thank you. Question. One question. First question.
I would like to ask, when you were on the slide with the products,
Yes.
you were talking about personalizing the explanations and predictions and so on to the
Yes.
to the advocate. Are you talking about personalizing for each advocate, or are you just learning from all advocates who are using the program, so you're getting a more generalized program that would fit all of them, or would a specific echo, if they could say, okay, I want a specific subset of explanations?
Yes, actually, there are some limits in both cases, of course. We are trying also to understand this. I mean, what in air traffic controller's opinion would be the best solution in this way. So, having the optimal generalized solution within the group or the personalized for each output. The main issue of that is that trying to do an average of the personalization, then it's no more a personalization. And if you personalize for every air traffic controllers, how can you be sure that every air traffic controller will find the ISO model at the workstation? So actually, this is something that we should analyze better, and we are trying to understand it also during the validation activities, since we are asking feedbacks and we are collecting some of them. So keep posted with ARTIMATION website, and you will find out the answer to this question.
Okay, thank you.
Thank you for the question. Any other question? Actually, this personalization is something that Mahalo will try to answer to, right?
That's the thanks.